Good morning, students. So, in our seventh chapter, let us continue with the next topic volume and surface area of combined solids. Okay, till now we have studied about different objects' volume, but we have not seen any combined one. We have seen a single object, that is only a cone, only a hemisphere, only a cylinder and only a sphere. Like that we have seen only one single object or what to say solid, but now we are going to see about combined solid. That is, we are going to join two solids and combine that, and we are going to find the volume and surface area. How to do that? Let us see. Now see here, to calculate the surface area of a combined solid, we should only calculate the areas that are visible to our eyes. For example, if a cone is surmounted by a hemisphere, surmounter means it is kept on that. Cone is kept on, hemisphere is kept on the cone, okay, surmounted. So we need to just find out the CAC of the hemisphere and CAC of the cone separately and add them together. How to find the surface area? We should just find the CAC of the cone and CAC of the hemisphere. Then you should just add both the things. So note that we are leaving the base area of both the cone and the hemisphere, since both bases are attached together and are not visible. ஸோ இங்கே பாருங்கள், இந்த இடத்துல வந்து இந்த ஹெமிஸ்பியருக்கு ஒரு பேஸ் இருக்குது அண்ட் கோனுக்கும் ஒரு பேஸ் இருக்குது. பட் வி ஆர் லீவிங் இட் பிகாஸ் உங்களுக்கு சர்ஃபேஸ் ஏரியா கண்டுபிடிக்கும் போதே அதெல்லாம் இன்க்ளூடட் மாதிரி தான், ஏன்னா அது ரெண்டுமே ஜாயின் ஆகிடுச்சு, மர்ஜ் ஆகிடுச்சு. ஓகே, ஸோ தென் பட் த வால்யூம் ஆஃப் த சாலிட் formed by joining two basic solids will be the sum of the volumes of the individual solids. That is, here வந்து நம்ம சர்ஃபேஸ் ஏரியாவுக்கு சிஎஸ்சி ரெண்டுத்தையும் ஆட் பண்ணுவோம். பட் ஃபார் த வால்யூம் ஆஃப் த ஹோல் ஃபிகர் வி ஷுட் ஜஸ்ட் ஆட் த வால்யூம் ஆஃப் கோன் ப்ளஸ் வால்யூம் ஆஃப் ஹெமிஸ்பியர். ஓகே, let us start with exercise 7.3, first question. Okay, a vessel is in the form of a hemispherical bowl mounted by a hollow cylinder. The diameter is 14 cm and the height of the vessel is 13 cm. Find the capacity of the vessel. Okay, so let this be the vessel. Okay, this is a hollow cylinder kept, that is mounted on a hollow hemisphere. Okay, so it combines and forms a just a vessel. Okay, we have so much vessel in our houses, but this is a different vessel. It will be a hollow thing. Okay, we'll pour something and keep it, no, like that, you can imagine. Okay, so what is said means the diameter is 14. Diameter, you know already, if it is joined to the base and this height, that is the top portion of the hemisphere and the bottom portion of the cylinder, if it is joined, then their both diameter and radius will be same. Okay, you can't have a vessel like this having larger diameter in the hemisphere and smaller diameter in the cylinder, not like that. Okay, so it has the same diameter till the end, from starting till the end. Okay, so we can take the radius of both the things as 7. Okay, 7 centimeter we can take it, and the total height is 13 centimeter they have given in the question. So what can we find here? Diameter 14, radius 7, total height 13 centimeter. Height of the cylindrical part. Okay, how to find the height of the cylindrical part? You know already, for a hemisphere the height and the radius are the same, because if it is a circle, then the height and the radius will be 2 radii of the circle. So you know radii are always equal, so this height and this radius is always equal, and it is equal to 7 now. So the total height is given 13. So from that, if we subtract 7 here, then what you will get? You will get 6. So the height of the cylinder is what? 6 centimeter. Therefore, the capacity of the vessel is capacity of the cylinder plus capacity of the hemisphere. Capacity also means as volume. Okay, volume of the cylinder is pi r square, we already know. So 22 by 7 into R is 7, 7 and H is 6. Okay. You should not put the H as 13. It is the height of the total vessel, but we have to find the height of the cylinder separately, then you should use it here. So 1717 cancel and multiply all these things, you will get 924. Okay. Next, volume of the hemisphere. Volume of the hemisphere formula is 2 by 3 pi r cube. Okay. So 2 by 3 pi, that is 22 by 7 into r cube means 3 times you should put r, that is 777. You will get 1717 cancelled and all the things if you calculate you will get 718.67. Okay. So what is the total volume of the vessel? How to find it? By adding the volume of cylinder plus hemisphere. So you will get what? 1642.67 centimeter cube. Okay. Second question. Nathan, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends. The diameter of the model is 3 cm and its length is 12 cm. If each cone has height of 2 cm, find the volume of the model that Nathan had made. So Nathan is an engineering student, so he was asked to make a shape which will be looking like this, because cylinder is attached to two cones, okay, at the end like this. He has asked to made. What they have given? They have given that the diameter of the model is 3 centimeter. That is, they have given only diameter of the model. They have not given that diameter of the cone or diameter of the cylinder. We can find from that, because see, if we take this as 3 centimeter, this and this both solids have the same combined shape, no, here. So this also will be 3 and this also will be 3. The diameter everywhere, but till here only it will be equal. From here it will not be equal, because cone is always what to say, that is, it is becoming narrower from here to here. Okay, so all the diameters will not be equal. Till the contact part of the cone it will be equal. So the diameter is 3 means what is the radius? 3 by 2. Okay, that is 1.5 you can keep, or you can keep it as 3 by 2 itself. What is the height? That is length of that solid means 12 centimeter. Okay, and also the cone's height is given. This is given, which is as 2 and 2. So how can you find the height of the cylinder? By subtracting 2 and 2, that is 4 from 12. If you subtract 4 from 12, you will get 8. Okay, so the height of the cylinder is 8. Okay, so we have to find the volume. Volume of the model is volume of the cylinder plus volume of two cones. Okay, pi r square h plus 2 into, that is, keep it as 2 into 1 by 3 pi r square h. Okay, volume of the cylindrical part 22 by 7, that is pi r square means pi into r. R is 3 by 2, I already told you. We can keep it as such because we can cancel it easily. 3 by 2 into 3 by 2 into 8, h is 8, height of the cylinder. Okay, so 2 and 8 cancels and 2 and 22 cancels. Okay, then nothing. So you will get 396 by 7, which is approximately equal to 56.57 centimeter cube. Volume of the conical parts 2 into 1 by 3 into 22 by 7 into 3 by 2 into 3 by 2 into 2. Here you should take the height of the cone, not the height of the cylinder or total height of that. Okay, no, you should take only cone's height, which is nothing but 2, given in the question. So when you cancel everything, you will get 66 by 7, which is 9.42 centimeter cube. Therefore total volume is what? Adding these two. So 56.57 plus 9.42, you will get 65.99 centimeter cube. The volume of the model that Nathan has made is 66 centimeter cube approximately, because just one point is there, so you can bring it to 66. Third question. From a solid cylinder whose height is 2.4 centimeter and the diameter is 1.4 centimeter, a cone of the same height and the same diameter is carved out. Okay, find the volume of the remaining solid to the nearest centimeter cube. What they are saying, a cylinder is there with a height of 2.4 centimeter, diameter of 1.4 centimeter. A cone is carved from it. carved means what to say, CV அதை எடுப்பாங்க தனியா. They'll take this part out and take this only part from that cylinder. Okay, they'll just throw this away, these remaining parts. So volume of the cylinder is pi r square h. How to find volume of the cube? By the formula 1 by 3 pi r square h cubic units. So D is 1.4 and R is 0.7, that is you can take it as 7 by 10 and this is 1 by 4, or you can your wish. And 2.4 is 24 by 10. This you no need to take because you are taking the radius. Volume of the cylinder is nothing but pi r square h. So 22 by 7 into R is 7 by 10 into R is 7 by 10 into H is 24 by 10. We have converted the decimal point into fractions. Okay, so you can cancel it now. When you cancel, you will get the 3696 by 1000. So 3 points. Okay, 30 means 3 points. 3 times you should move the point. You will get 3.696 centimeter cube. Volume of the cone carved out is nothing but 1 by 3, that is 1 by 3 pi r square h means 1 by 3 into 22 by 7 into R is 7 by 10 into 7 by 10 into H is same 2, that is 24 by 10. So when you cancel and calculate all these things, you get 1232 by 1000. Okay, so 3 zeros, you should move the point 3 times. 1.232 centimeter cube. Therefore, volume of the remaining solid is what? How to find the remaining solid? So, if you take a cake, when you cut it in 4 pieces and you take one piece out, if they're asking to find the remaining piece, how did you find it? You will take this whole, this whole cake, and then you will take the, find what amount of cake you have ate from that, and you will just subtract this amount from the whole thing, then you will get the remaining. Like that we can find, first we should find the whole volume of cylinder, then we should find the volume of the cone. When you cut this cone from that, you will have the remaining things out there, so you can find it by subtracting volume of cylinder minus volume of cone. Okay, so 3.696 minus 1.3232, you will get 2.46 centimeter cube. That is, I have converted to the nearest centimeter cube. A solid consisting of a right circular cone of height 12 centimeter and radius 6 centimeter standing on a hemisphere of radius 6 centimeter is placed upright in a right circular cylinder full of water such that it touches the bottom. Okay. Find the volume of the water displaced out of the cylinder if the radius of the cylinder is 6 centimeter and height is 18 centimeter. So what they are given? They are given a cylinder. Okay, a right circular cone is inserted to it. Okay, and also before that right circular cone, we have also inserted a hemisphere in it. Also we have water. Okay, inside that solid we have water, full of water. Okay, so now when you insert a hemisphere inside and a cone inside, obviously the water will spill out. Okay, we have to find the volume of water displaced out of the cylinder. If the radius of the cylinder is 6 and height is 18, they have given the radius and height of the cylinder, and also they have given the radius and height of the cone. Okay, only the radius of the hemisphere is enough because the same thing will be for cone also. So one thing is given means it is okay. Okay, so let us start how to do it. Okay, just understand this question. It is very important. You can understand it easily, but concentrate on it. How to do it means, if the water is filled here till here means how much ever volume you are inserting inside the cylinder, that much amount of volume of water will come outside the cylinder. Did you understand? I'll tell it again. When you how much amount of volume will be inserted inside the cylinder will be split by the water also. The same volume will be there for these two solids and the water split out. Okay, so how to find it? You should find the volume of this thing. Okay, so volume of the water displaced out is volume of the solid immersed in it. Immersed means inserted in it. Okay, so volume of the solid is nothing but volume of the cone plus volume of the hemisphere. Okay, so volume of the cone is nothing but 1 by 3 pi r square h, which is 1 by 3 into 22 by 7 into r is nothing but 6 and 6 into 12 is nothing but the height of the cone. So you will get 452.57 centimeter cube. Keep this as equation number 1. Volume of the hemisphere is nothing but 2 by 3 pi r cube and 2 by 3 into 22 by 7 into 6 into 6 into 6. So you will get 452.57 centimeter cube. The volume of the water displaced out is nothing but the volume of the solid. That is equation number, let this be equation number 2. Okay, that is equation number 1 plus 2. You will get 905.414 centimeter cube. Okay, fifth question. A capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. If the length of the entire capsule is 3 millimeter, how much medicine it can hold? They've asked. Okay, the volume we have tubed, they will be called as tube tablets. Okay, it will be looking like tubes and it will be attached to a cylinder, hemisphere and with a cylinder. Okay, width is, that is the length, the total length is 3 millimeter they have given. Okay, 3 millimeter. 3 millimeter is nothing but the length means, here it is, you can know that by general knowledge we know that the capsule will be somewhat more than 1 centimeter. We already know that somewhat more than 1 or 1.5 centimeter, but they are given 3 millimeter here. How can this be possible? They can't create a capsule for 3 millimeter. So we should understand here that they are telling about the radius, that is diameter they are telling about. Like that we should understand. Okay, so the volume of the medicine in the capsule can hold is nothing but the volume of the cylinder plus volume of the hemisphere. That is 2 volume of the hemisphere, 2 into, because the same radius, same height. Okay, so we can consider it as 2 into the hemisphere. And volume of the cylindrical part is nothing but pi r square h 22 by 7 into r square is, this is given as diameter. Then what you can do, 3 by 2 you can take as radius. So 3 by 2 into 3 by 2 into 6. The height is 6 millimeter. Okay. And you cancel it, you will get 42.428 millimeter cube. Okay. Then volume of the two hemispherical parts is nothing but 2 into 2 by 3 into pi r cube. Okay, so 2 into 2 by 3 into 22 by 7 into 3 by 2 into 3 by 2 into 3 by 2. So when you cancel all the things, you will get 14.142 millimeter cube. Therefore, the total volume is nothing but, when you add these two, you will get 56.571 millimeter cube. Therefore, the volume of the medicine in the capsule can hold 56.57 millimeter cube. It can hold that much amount of medicine. Okay. Sixth question. As shown in the figure, a cubical block of side 7 cm is surmounted by a hemisphere. Find the area of the solid. You can see surmounted means kept on it. Okay, a cubical block is there and it is surmounted by a hemisphere. Okay, it is surmounted by a hemisphere. We have to find the surface area of the solid. Okay. Also the side of the solid, that is cubical block, is given 7 cm. Clearly, greatest diameter of the hemisphere is equal to the length of the edge of the cube. Okay, the greatest diameter of the hemisphere is equal to the length of the edge of the cube is 7 cm. Like that it is given. How to see? If the hemisphere is surmounted means it is perfectly kept on the cube. Like that you can imagine. Okay, it is perfectly, it will be looking larger than the one side of the cube when it is kept on it. Then only you can find the diameter from that. Okay, the diameter and the edge of the square is same, which is 7. Then the radius of the hemisphere, this part of the question is very important. When you understand this only, you can move on to the sum. So radius of the hemisphere is nothing but half of the diameter, which is nothing but 7 by 2 centimeter. Now total surface area of the solid is nothing but surface area of the cube plus curved surface area of the hemisphere minus area of the base of the hemisphere. Why I am subtracting this base means the base of the hemisphere is kept on the square, that is cube. Okay, so the one edge of the square and the base of the hemisphere will be combined. Okay, so they will not be visible outside, so you should cancel that base area of the hemisphere. Okay, because the curved surface area of the hemisphere will be will be the upper portion and not the lower portion, so you should cancel the lower portion. So 6 into 7 square plus 2 into 22 by 7 into 7 by 2 whole square minus 22 by 7 into 7 by 2 whole square centimeter cube. Okay, this is pi r square. Okay, the area of the base is nothing but it will be looking like a circle, so we should take the area as circle. Okay, circle's area. Then the 6 into 7 square is nothing but this cubical blocks area. Okay, 6 into 7 square. You know the total surface area of the cube is nothing but 6a square, that is 7 square into 2 into 22 by 7 into 7 by 2 whole square means it is a curved surface area of the cone. Sorry, the hemisphere, 2 pi r square. Sorry, it is a hemisphere. So when you calculate all these things, 294 plus 77 minus 77 by 2 centimeter square. So you will get 294 plus 77 by 2 centimeter square. So you will get 332.5 centimeter square. Seventh question. A right circular cylinder just encloses a sphere of radius r units. Calculate the surface area of the sphere, the curved surface area of the cylinder, the ratio of the areas obtained in the cylinder. Okay, they are telling that from a right circular cylinder, a sphere is there. Okay, inside that a sphere is there. We have to find the surface area of the sphere. Surface area of the sphere is nothing but 4 pi r square. That is, we have to derive the formula. So we have found it 4 pi r square. CSA of the cylinder is nothing but 2 pi r into h. You already know the formula. So 2 pi r into h is nothing but 2r. So when you do that, you will get 4 pi r square. Okay. So then we have to prove that these two are same. Ratio is nothing but 4 pi r square by 4 pi r square. You will get 1:1 as ratio, because same. These both are same means you will get 1:1 only. Okay. Eighth question. A shuttlecock used for playing badminton has the shape of the frustum of a cone, is mounted on a hemisphere. Okay, it will be looking like this, no? So it will be looking like this. It is a frustum of the cone joined with a hemisphere. Okay. The diameters of the frustum are 5 cm and 2 cm. The big one will be called as 5 cm. That is, diameter will be 5 cm and the small one will be 2 cm. Then what is the small ones and the difference of the hemisphere base? There is no difference because these both are joined, means both has the same diameter. Okay. So then the height of the entire shuttlecock is 7 cm is given. This is given 7 cm. We can find the height of the frustum. How? By subtracting the height of the hemisphere. We already know radius and height of the hemisphere are same. So if it is 1 centimeter, then the height also will be 1 centimeter. When you subtract 1 centimeter from 7 centimeter, you will get 6. Okay. External surface area of the cock is nothing but surface area of frustum plus CSA of hemisphere. CSA of frustum is nothing but pi into r plus r into L. R plus r means big radius, small radius, and into lateral surface area. So r equal to 5 by 2. Because the diameter is only given as 5, but the radius is 5 by 2. Then small r is 1. Then L is nothing but what? The lateral surface area of the frustum. So root of r minus r whole square plus h square. You already know the formula. So 2.5 minus 1 whole square plus 6 square. 1.5, that is when you subtract 2.5 and 1. 2.5 and 1.0, you'll get 1, and 2 minus 1, 1. So you'll get 1.5 whole square plus 6 square is 36, and you'll get 2.25 when you multiply 1.5 into 1.5 plus 36. Then you will get root of 38.28, which is approximately, when you calculate the square root, you will get 6.18 approximately. Okay. So CSM, the frustum is nothing but 22 by 7 into 3.5 into 6.1. Okay. I am not taking the 8 because it will be easy to calculate. So for 67.7 by 7, we will get 67.1 centimeters square. CAC of the hemisphere is nothing but 2 pi r square, 2 into 22 by 7 into r is nothing but 1 into 1. So you will get 6.28 centimeters square. Therefore, the total external surface area is nothing but, adding these two, 73.38 centimeters square. Approximately, it is nothing but, you can convert this 8, that is, it is going on something. So I have converted these to 3 point, that is 0.39, 73.39 centimeter cube approximately. Okay.